Problem. The lifeguard wishes to rescue a swimmer 120 feet down the shore and 50 feet into the water. The lifeguard can run at 20 feet per second and swim at 5 feet per second. How far along the shore should the lifeguard run before jumping in the water in order to get to the swimmer as quickly as possible? So if we were just minimizing the distance, the lifeguard would go directly into the water and directly to the swimmer. But we want to that's not necessarily going to give us the fastest time, because the lifeguard swims slower than the lifeguard can run. So so we want to minimize the time, which is not necessarily going to be the same as the minimum distance. So the lifeguard is going to, if either the lifeguard will go directly into the water, or it'll go 120 feet along the land, or maybe it will be somewhere in between. If it's somewhere in between, the picture looks something like this. We have distance x along the through the water, along the land, and then the remaining distance, 120 minus x, is through the water. So this, so the distance through the water, we'll have a right triangle here. The distance through the water is going to be, there'll be an angle. It'll be the square root of 120 minus x quantity squared plus 50 squared. That's the Pythagorean theorem. Okay, so so this only makes sense if x is between 0 and 120. We're not. X less than 0 would mean the lifeguard is running in the opposite direction. X more than 120 means that the lifeguard is running past the swimmer. So this only makes sense for x between 0 and 120. So this is a closed interval. So we just have to evaluate the two endpoints and any critical numbers in order to find out the minimum time. Okay, so the time, we want to write. So what we're trying to minimize is the time. We want to write down a formula for the time. The time is the distance divided by the rate. And part of that will be on land, part of it will be in water. So T of x, and the land portion of it is going to be whatever distance the lifeguard runs divided by the rate along the land. So it's what x divided by 120. So the land portion of that is x over 20. And then the part in the water, the distance in the water is square root of 120 minus x 20 squared plus 50 squared, and we want to divide that by the rate in the water. Which is 5 feet per second. Okay, so I'm going to write this a little bit differently. This is 1 over 20 times x plus 1/5, and the quantity 1 minus 20 minus x quantity squared plus 50 squared to the minus 1/2 power. And then we want to take the derivative to get the critical numbers. So t prime of x, this first term was going to just be 1 over 20. And then we want to use the power rule, so it'll be negative 1/5 times negative half times 1/5 would be 1/5 times minus 1/2. No, this is positive 1/2. I don't know why I put negative there. 1/5 times 1/2, and then the exponent, the new exponent is going to be to the negative 1/2. So this is going to be 120 minus x quantity squared plus 50 squared to the negative 1/2, and then we have to times it by the derivative inside, which is going to be 2 times the quantity 120 minus x times negative 1. Okay, so so then we can the 2 and the 1/2 will cancel. And we can take the minus sign out in front. So this will be, and I'll rewrite this as a radical, this negative exponent. So we'll have 1 over 20 minus 1/5, and we'll have 120 minus x over the square root of 120 minus x 20 squared plus 50 squared. And we want to set this equal to 0 to get the critical numbers. So we'll set that equal to 0, and so that means that we can add I'll put an implication here. We want to add the 1/5, move one of these terms over to the other side. We have two terms here, so let's move one of them over to the other side of the equal sign. We'll have 1 over 20 is equal to 1/5 120 minus x over square root 120 minus x quantity squared plus 50 squared. And let's multiply everything by 20 to get rid of the fractions here. We'll have 1 equals 4 120 minus x over square root 120 minus x quantity squared plus 50 squared. And we can multiply by the denominator to get rid of fractions here. We'll have square root of 120 minus x quantity squared plus 50 squared equals 4 times the quantity 120 minus x. And now we can square both sides. We isolated the square root, so we can square both sides and get rid of the square root symbol here. So this will give us 120 minus x quantity squared plus 50 squared is equal to 16 times the quantity 120 minus x quantity squared. And then we can subtract the 120 minus x squared from both sides of the equal sign. And that will give us 50 squared equals I have 50 squared equals 15 120 minus x quantity squared. Okay, so then we can I guess divide both sides by 15. We'll have 50 squared over 15 equal 120 minus x quantity squared. And then take the square root of both sides. We have plus or minus 50 over root 15 equals 120 minus x. And then we can move the x over to the left and move the other term over to the right. We get x is equal to 120 minus 50 over plus or minus 50 over root 15. But x has to be between 0 and 120. And so if we use the plus, we're going to get something more than 120. So that means we want only the negative root here. We have x equal 120 minus 50 over root 15. And let's simplify this a little bit. Let's get the root 15 out of the bottom. Take that out of the bottom there. So we have x equals 120 minus 50 root 15 over 15. We can then reduce this. This is divide top and bottom by 5. X equal 120 minus 10 root 15 over 3. Let me just check my work here. See, T. Okay, so I guess, yeah, I'll leave it like that. Okay, okay, so now we want to evaluate the function at the two endpoints and the critical value. So let's and we just have the one critical value. So go to we have t of 0, two endpoints. Let's review t of x. Remember is x over 20 plus square root 120 minus x 20 squared plus 50 squared all over 5. Okay, so t of 0, we're doing t of the endpoints as 0 over 20 plus the square root of 120 minus 0 squared is 120 squared plus 50 squared over 5. So this is going to be square root of 12 squared is 144, and then we have two zeros. 5 squared is 25, and we have two zeros. This will be square root of 169.00 over 5. Square root of 169 is 13, and add a 0. So this is going to be 26 seconds. So t of 0 is 26 seconds. So if the lifeguard jumps directly into the water, it'll take 26 seconds to reach there. T of 120, the lifeguard runs as far as the maximum distance along the land before jumping in the water. It's going to be 120 over 20 plus square root of 120 minus 120 is 0, so it would be 0 squared. So plugging in 120 into here, 120 minus 120 is 0. 0 squared plus 50 squared over 5. So it's 120 over 20 is 6. 6 plus square root of 50 squared is 50. 50 over 5 be 6 plus 10, which is 16 seconds. So if the lifeguard runs the full distance along the land, there's still a portion where the lifeguard has to swim. So it's going to be 6 seconds along the land and then 10 seconds in the water. And the other, so those are the two endpoints. And then we also want to evaluate at the critical point. So let's, what that is, again, t of x is x over 20 plus square root 120 minus x squared plus 50 squared over 5. So we want t of, and it was 120 minus 10 root 15 over 3. So this is going to be 120 minus 10 root 15 over 3 all over 20 plus square root. Well, 120 minus 120 is 0, so you just have 10 root 15 over 3 squared plus 50 squared over 5. So 120 divided by 20 is 6, and this will be minus, and this will be root 15 over 6. It's going to be 10 over 60, which is 1 over 6. And this part here, I have square root, root 15 squared is 15, so we'll have 10 squared is 100 times 15 over 9. 3 squared is 9 plus 50 squared over 5. Okay, so 15 over 9 reduces to 5 over 3, so this is 500 over 3. 6 minus root 15 over 6 plus square root 500 over 3 plus 50 squared over 5. If we multiply top and bottom by 5, we have 6 minus root 15 over 6 plus 2500 over 15 plus 2500 over 5. And then we can factor out the 2500. Square root of 2500 is 50. And then 50 divided by 5 is 10. So this is 6 minus root 15 over 6 plus 10. And we'll have square root of 1 over 15 plus 1. And so this is 6 minus root 15 over 6 plus 10. This will be 16/15. And square root of 16 is 4. So this will be okay, so we'll have 6 minus root 15 over 6 plus square root of 16 is 4, so we have 40 over root 15. Okay, so let's multiply top and bottom by root 15. 6 minus root 15 over 6 plus 40 root 15 over 15. And we can reduce that. 15 over 6 plus 8 root 15 over 3. And then get a common denominator. So this will be 6 minus root 15 over 6 plus multiply top and bottom by 2. 16 root 15 over 6. 6 will be 6 plus 15 root 15 over 6. Now we can combine the two fractions. And this, we can reduce 15 over 6 reduces with 6 plus divide top and bottom by 3, 5 root 15 over 2. Okay, so that's the time at the critical value, but it's now we could put this in a calculator, or without a calculator we can still sort of estimate with this. We know this is going to be less than 6 plus 5 root 16 over 2. Root 16 is 4. 4 times 5 is 20. 20 divided by 2 is 10. So this is going to be less than 16 seconds. If you put in a 16 here, you get 16 seconds. So let's make a table, sort of a summary table here, of the time at the two endpoints, and also the critical point. So when x is 0, that means the lifeguard jumps directly into the water, 0 feet on land. The time is going to be 26 seconds. If the lifeguard runs 120 feet along the land, the time is going to be 16 seconds. If the lifeguard runs, what was it? It was 120 minus 10 root 15 over 3, then it's going to be a little bit less than 16 seconds. Okay, and so this is the minimum time then. The minimum time is going to be occur when x is 120 minus 10 root 15 over 3. So it's the minimum time occurs when the lifeguard runs part of the distance along the land before going into the water. And that concludes this presentation.